So today we're going to be covering the column of questions 88 through 93. It's one of the shorter columns, so without further ado, let us begin. So we are looking at question 88 right here. And question 88 says, which quadrant contains the following signs? The cosine of theta is going to be greater than 0, and the sine of theta is going to be less than 0. Okay? Well, let's use the trick that we've done previously, where we use all students take calculus. So I know that the cosine of theta is greater than 0, and the sine of theta is less than 0, which means the cosine is positive and the sine is negative, is really what we're looking at here. Okay? So when we have that, let's go ahead and draw our unit circle. We know all students take calculus. Well, the cosine is going to be positive here and here with all students and the calculus, or the all and the calculus. So cosine is positive here and here. When we're looking at the sine being negative, well, the sine is going to be positive in the top two, all and sine, so all and students. So it must mean it's negative down here and here. So the only quadrant where both cosine is positive and sine is negative is going to be this quadrant, which is going to be quadrant 1, 2, 3, 4. Boom. Okay. That was question 88. Let's take a quick look at question 89. Okay. 89 says, if the sine of theta is equal to negative 8 over 17, and 270 degrees is less than theta, which is less than 360, then what is the value of the cosine of theta? Okay, so let's unpack a little bit of this. So I know that the sine of theta is negative 8 over 17. I know theta itself is above 270, but less than 360. Okay? And I want to know the value of the cosine. So cosine of theta equals blank. Okay, so with this, I know that my angle measure, I know which quadrant it's going to be in. Okay, I know that if I have an angle measure between 0 and 90, 90 and 180, 180 and 270, 270 and 360. So my angle measure is going to be down here, okay? Which means my triangle is this triangle right here. Furthermore, I know that the sine of that angle right here, sine is opposite over hypotenuse from SOHCAHTOA. The opposite of that angle is going to be right here. That must be where the negative 8 comes into play, because I know that is the y value, and the y value has to be negative. And if the 8 is negative, that means the hypotenuse must be positive. Okay? So I've got those two sides of a triangle. I need to figure out what cosine is, which relies on this third angle. So the only way to find that third leg, the only way to find the third leg is use the Pythagorean theorem. A squared plus b squared is c squared. I know a and b are the two legs, or these two values. And I know c squared is going to be the hypotenuse, or this value. Perfect. So all I need to do is solve for a. I'll figure out that length, and then I can plug it into my function over here. Okay. So negative 8 squared is 64. 17 squared, well, I'm not necessarily familiar with my 17 squares off the top of my head. So 17 times 17, it's going to give me 289. That should be a plus. So I take 289, I subtract my 64, I get 225. And here I know a is going to be equal to the square root of 225, positive or negative, which is positive or negative 15. Now here's the kicker, that positive or negative 15 depends on where it's located. In this case, I know it's going to be a positive 15, because my x value right here is positive. This same triangle could exist over in this quadrant, which is why when we take the square root, we always take a positive or negative, because I don't know where exactly that triangle lies. Over here, or over here. They'll both have a radius of 17. They'll both have a y value of -8. This one's a positive. This one's a negative. But regardless, now that we know that this is a positive 15, we've got everything we need to answer our question. Cosine, which we know to be the adjacent over the hypotenuse, is going to be 15/17. And yes, I used my blank as part of my fraction. Awesome. So there we go. That was number 89. Let's take a quick look at number 90. So number 90, very similar style question. I have the cosine is 20/29. I know that my angle is between 0 and pi/2. And I want to find the value of the sine of that angle. Okay, so let's take a look at what we know. So the first thing that we know is where our angle is listed in. It's between 0 and pi/2. So that must mean that pi/2 is right here, because pi, half of pi, it's somewhere in this region. I know that the triangle that it creates is right here. And of that triangle, we have SO, CA, TOA. I have the cosine, which means I have the adjacent and the hypotenuse. Okay. So the adjacent side of that angle is going to be 20. The hypotenuse is going to be 29. If I want to find that missing leg, all I need to do, like I did before, is use the Pythagorean theorem. So a squared plus b squared is c squared. C squared is the hypotenuse, so 29. And then a and b are the two legs, one of which I know, one of which I don't. Perfect. So I just need to solve for a. Actually, let's zoom in a little bit. I think we're a bit far out. Yeah. So a squared is 400 plus 400 is equal to whatever 29 squared is. Again, I don't know about you, but I don't know what 29 squared is. So 29 squared is 841. If I subtract 400, I get 441. Okay? And if I square root that, let's see, square root is going to be 21. So now a is either positive or negative 21. We're not sure which. We have to look at our triangle to figure that out. So this triangle could be going up or it could be going down with those two values. In this case, I know that my a is equal to a positive 21. Awesome. And so that is all I need to answer my original question. Sine is opposite over hypotenuse, 21 over 29. There we go. So that was question 90. Let's take a quick look at question 91. Okay. So what I've gone on here is we want to state the period and the amplitudes of these two functions. Okay. So for 91, we have y equals 5 times the cosine of 4x. Okay. Well, as far as the amplitude is pretty straightforward. It's the number out in the front. It's the coefficient of my trig function. So the amplitude is 5. If you want to find the period, it's going to take you just another minute. The period is going to be 2 pi divided by whatever the coefficient of x is. So 2 pi divided by 4, or pi over 2, is the period. Awesome. So that was question 91. Pop over to the next one, question 92. So question 92 is the same thing. -6 sine of 1/2 x. So pretty straightforward. The amplitude is going to be that number right here. Now what they're trying to check is that the amplitude is just going to be 6. Because again, remember the amplitude is the distance from the midline either to the peak or to the trough. And simply because we know that is a negative, I'm starting right here. but the amplitude repeats itself, so, or the function repeats itself, so it doesn't matter if the amplitude is positive or negative, it's always going to be a positive value. The distance from here to here is 6, the same from here to here is 6. Even though I'm looking at it from the -6 perspective, the amplitude is just plain old 6. Now the period will be, again, we know it's going to be 2 pi divided by this coefficient, which is 1/2. In which case I'm going to need to solve this complex fraction by keep, change, flip. 2 pi, change it to times, and flip this to 2/1, which is just 4 pi. So my period is 4 pi. There we go. Okay, and so that was 92. Let's take a quick look at number 93. Okay, so 93 says, we're looking at this graph below. We want to give the amplitude and the vertical shift of the graph. Okay, so when we're solving this, I'm really looking at where is the midline on my graph. Well, if I go from 5 to -3, let's see, 5 minus -3 is the same thing as saying 5 plus 3. I have a total distance elapsed here of 8. I know the midline is half of that number, which is going to be at 4 units away from either the peak or the trough. So if I go 4 units away from this thing, I'm going to say, okay, 1, 2, 3, 4. That is my midline. So my vertical shift is going to be moving up or down from that position. Okay. So I'm going to use that information and say my vertical shift is up by 1 unit. The middle of my wave is 1 unit above the x-axis. Now the amplitude, we figured out the amplitude by finding the midline. The amplitude is 4. Boom. That's it. And there we go.